Good morning. Going to pick up where we left off with the secondary growth, which remember is the increase in girth of your roots and your stems. So, a couple. Next thing that we're going to talk about is some of the things that the plants have in place to prevent the vascular cambium from bursting. Sorry. So basically what they end up doing is they create these dilated phloem rays, which I have drawn on the back side of your diagrams there. So you can kind of see that they're going to create these rays that are kind of come out of that cambium. So they will also divide, I guess laterally you might call it. So not only will they grow these dilated rays, but they'll also grow in circumference. So that way the cambium doesn't explode or lyse, I guess, in that case. So these phloem rays, there's gaps in between the rays themselves. And what happens in here is they'll end up forming these this cork. The cork will end up forming. We call this structure the cork cambium. Cork is a really good insulator and protector. So we don't actually have anything that as far as I know, we haven't been able to synthesize something in the lab that has all of those natural properties of cork. So it's a really good material that the plant develops to help protect it. So I've drawn you the picture kind of the cork cambium there. So to kind of help give that insulation, the plant will develop this cork. So that inner ring there is going to be where is going to separate that secondary xylem and phloem. I've kind of drawn a couple of cells there for you. Then the outer ring there that's your cork cambium. So what ends up forming on the inside, because remember you're going to form stuff to the inside and to the outside. To the inside you're going to form what's called phyloderm, and then to the outside you're going to produce the actual cork, which is called phloem. So in between the phloem or the cork cells, you're going to have some loosely packed parenchyma cells that are going to be called lenticels. Because cork is so impenetrable to water and oxygen, you need these lenticels to be able to allow water to come into the cell. Otherwise, you wouldn't be able to get water or oxygen into the stem there, which would obviously be a bad thing. So your cork cambium, your cork, and your phyloderm Collectively, those are all called the perioderm. Okay, so your perioderm is just your cork cambium, the cork or the phloem, and then the philoderm. So what makes the cork and the phloem and the philoderm of the cork there. So if you look below, I've also got some pictures of the roots, which would be next. Got the secondary growth in the root systems. It's going to be really similar to the stems. So I've drawn you on the far left. You've got your pericycle there. And then that's what I've enlarged for you. And so from that, you get the vascular cambium. It's part of the pericycle and part of the undifferentiated procambial cells. And that's going to produce those primary and secondary phloem tissues to separate the secondary xylem and phloem, which will separate the primary phloem and xylem. There we go, sorry. So, and then eventually this will also produce some cork and philoderm, which is that last picture that I've drawn you. You got your philoderm to the inside and your cork to the outside. And you got your vascular cambium on there on the inside, and then the cork cambium. So, so that kind of it does a lot of the same development that that your stems will do. So, okay. Just making sure I've got everything here. Okay, so moving on. Tomorrow we'll do a little bit more onto the wood anatomy, but we're gonna introduce the wood here. And so you can have two different types of wood. You can have softwood and you can have hardwood. And it's not actually about the texture itself. It's more about what the wood appears to be like. So your softwoods are going to be found kind of in the conifer families. And so it's going to appear soft, kind of like you could scratch it a little easier than you could with your fingernail than against, say, a normal tree trunk would be what I would consider a little harder. So it just looks softer. So the reason why they appear softer is they are made up of tracheids and parenchyma cells. So that's why they appear soft, just because of what it's made of. Your hardwood is going to appear to look coarse or hard. It's not that it's any harder than the softwood, it's just what it looks like. So these particular ones are going to be found in dicots a lot of times, and they're going to be made up of secondary xylem, vessel elements, tracheids, fibers, and parenchyma cells. So, like I said, we'll go more into that. This is where it was input into the lecture, so we went and put it in there. So, but we'll talk now the last little bit about the annual rings that kind of form, since we talked earlier about the annual, perennial, biennial plants. So we've got these two different types of wood based on when they're made. It can be hard or soft wood. This is a different classification. I guess it's not classified based on what it looks like or what it's made of. It's going to be more about when it was formed. So every year your plants are going to produce secondary xylem, more secondary xylem, because they're always going to increase in girth a little bit. And so depending on what time of year it is, you're going to get either spring wood, sometimes it's called early wood, or you're going to be called summer wood, which would be sometimes termed late wood. I've drawn you some pictures there of the spring wood and the summer wood. Spring wood is formed earlier. That's why it's oftentimes called the early wood, formed during the springtime. And with this, you're going to get thinner cell walls. So then if you look next to it, later on in the year, you're going to get the summer wood formed. And summer wood ends up forming thicker cell walls. And I don't know how well I don't know how well it copied. I can see it, but I don't know if you can tell. But you can see that those cells are a little bit thicker. Those secondary xylem components are a little bit thicker, and so you can tell that in terms of color differences. So based on that, both those two together, that's going to determine your annular ring. Basically, how much growing was done in one growing season. Obviously, this is only going to occur in perennial plants. It can't really occur in annual plants because they're going to die, every year, and this implies that you're going on. So anyway, and then the last thing to note is that depending on what the weather is, that might determine how much of each type of wood will be produced. It might also kind of affect how those particular cells look. So it could be a little bit of both, not only what they look like, but what's produced. So that pretty much wraps up the secondary growth. If you do have any questions, please don't hesitate to ask. Quiz on Friday will include this and everything before it, but it won't include tomorrow. So if you do have any questions, just let me know. Otherwise, have a good day.